Good morning, everyone, and thank you for attending the 7th episode of ORAC 2.0, ORAC's new informational webinar series. ORAC 2.0 has been a huge success so far, and we are honored to have Enbridge Gas sponsor this episode. I would like to do a quick introduction before I pass the reins over to our speakers for today. My name is Paul Wrigley. I'm Vice President of ORAC and member of the Associates Committee at ORAC. We also have Amy Carpenter and Jessica Shaver on the line from the ORAC office to help with any technical issues and to assist with moderating questions. Presenting today's webinar will be two gentlemen from Enbridge, Joe Mariano, who will update us on incentives available from Enbridge, followed by Frazen Rad, who will introduce some natural gas heat pump products. Before we jump into the webinar, I would like to do a short Zoom tutorial. I know most of you are familiar with using Zoom nowadays, but we will quickly touch on a couple of points that are relevant to this webinar for those who are not so familiar with the platform. Ensure that you are logged into this Zoom webinar on either a computer, a smartphone, or a tablet so that you have access to all features of the webinar. All attendees in this webinar have been muted to provide the best experience for both the presenters and the viewers. If you have any questions during the webinar, please enter them in the Q&A box. Your questions will be then answered directly in the Q&A box or verbally by the presenter at the end of the presentation. At this point, I'd like to turn things over to Joe Mariano to to update us on the incentives available from Enbridge. Over to you, Joe.
Okay, great. Thank you, Paul. Hello, everyone. Thanks for joining the call today, and thanks to the ORAC team for organizing this. I'm Joe Mariano, pleased to be here. I'm an energy advisor at Enbridge, and I help work with a lot of business partners to make the incentive process as easy as possible. So I'll talk a bit about how we can work together to get customers some money back, whether it's a new build project or a retrofit. There's lots of incentives available. Okay, so I'm not seeing the slides. Are the slides up on the screen?
Joe, I didn't know. I thought you were
okay, yeah, I can do that. One second. Okay, are we seeing the slides okay right now?
The slides aren't on the screen right now, so just if you hit the share screen button at the bottom of the Zoom, it should bring up your screens to share, and you can select the PowerPoint.
Yep. Okay. Sorry about that, folks. Are we okay now?
Yep.
Okay. We want it on full screen here. Okay, 1 second. Okay, sorry about that. Okay, so we'll move to the map here. So when you take a look at this map, you see the Enbridge franchise area across Ontario. I'm sure you already have heard that Union Gas and Enbridge merged last year. So we are now serving over 3.7 million customers. We're the largest natural gas storage, transmission and distribution company in North America. And we have account reps all across the province that can help with the commercial industrial incentives that are available. So what are some of the incentives available? We have fixed incentives and custom incentives, and as well we have funding available for studies and operational improvements. So I'll start with the fixed incentives. It's more or less a coupon approach where there's a fixed incentive for a specific equipment. It's a simple one-page application form that we can help you fill out as well for the customer. And we have incentives available for service providers and distributors as well for helping with that process. So it's $50 to $100 a unit. All the equipment you see here listed would all fall under our fixed or prescriptive incentive program. Everything from makeup air units to demand control ventilation, ERVs, anything you see listed here. Our main commercial incentive program is our custom program. So 80% of the projects that we work on are under custom. So you let us know about the project early on, and anything the customer is doing that will reduce their gas load, we would be able to provide an incentive for that in most cases. So we do lots of boiler retrofit projects, controls, heat recovery, building automation systems. We determine the incentive based on the M-cube savings. So we will calculate the savings by establishing a baseline. So what's installed now, how is it operating? Then we look at the efficiency of the new equipment being installed, and we'll calculate the savings based on that and pay the incentive based on the M-cube savings. You can also provide a letter that you can take to the customer and show them, you know, we're working with Enbridge. Here is what the rebate would be if you move ahead with the projects, and here's how much you'll save on gas annually. So get in touch with us. We definitely want to help you with your projects. So let's look at a couple examples. This slide shows an example at a multi-res building where they installed a makeup air unit with VFD. They lowered gas consumption by 21%. The project cost $23,000. The incentive was almost $8,000, and they saved $12,000 a year on their gas bill. So it turned out to be about a 1-year payback. Here we have a boiler retrofit project at an office building. In this case, they installed high efficiency boilers, a $16,000 incentive, $125,000 a year saved, and a 3-year payback. And a controls project at the Rogers Center, controlling the air dampers and natural gas valves. They reduced their gas consumption by 39%, saving $25,000 a year and $11,000, over $11,000 incentive. And one more example at a post-secondary school, installed a BAS system for 2 buildings, reduced utility costs by 40%. They saved over $1 million a year and got $200,000 back from Enbridge. So that's about it. Just wanted to give you a quick few examples before I turn it over to Farzeen. There's my contact info. Please contact me anytime. We'd love to work with you. Any project that you're working on, whether it's big or small, I promise we'll make the incentive process easy. And I'll pass it over to Farzeen, and we'll take some questions at the end. Thank you.
Hi, everyone. Do you hear me okay? Okay, thank you. I had some difficulty earlier, so I just fixed that out right in time. So thanks, everyone. Let me share my screen here, and I can continue my presentation. Okay, so this is about the gas heat pump. My name is Farzeen Massoumi Rad. I am Senior Advisor in Enbridge, working on new and emerging technology, pushing new trends for energy efficiencies and reduction of the emissions, plus the increasing the gas load for our company. So this is one of the technology gas heat pump. So I'm going to cover the following topics. So just briefly describe what is gas heat pump, talking about type of gas, the heat pumps, and also the history behind it in Ontario, and also telling why heat pump now, and what is the gas, what is this technology, what is it as an opportunity for Enbridge, and talking about the acceptance barrier of this technology as it is new, and explain some new studies and demonstration project that we have done so far. And at the end, I will provide some resources for you guys to hang on in the future. And while I'm talking, welcome if there is any question, and I can address that as I can based on the limited time that I have. So starting with what is a heat pump. So basically, heat pump is nothing just a appliance that extract heat from the source and provide it to the heat. So it is basically a vapor compression mostly cycle. So from evaporation compression, this heat and cool can be generated. So so in this, for example, let me just turn it out so here, for example, in cooling mode, rejecting heat outdoor and providing cool indoor, and it would be reversed in the heating mode. So type of heat pumps, so we have electric and gas. So basically electric is just motor driven vapor compression, and gas heat pump, there are several types and technologies. From engine-driven gas heat pump, absorption type or sorption type in general, and thermal compression cycles. So basically for comparing gas engine-driven heat pump with just electric motor heat pump, is just replacing the motor for driving the compressor with the gas engine equipment for driving the compressor in the cycle. So there are different types, as I mentioned, gas engine, which is running the same vapor compression by electric gas motor, gas engine, and we have absorption type that is driving as a kind of, instead of compression of the gas over refrigerant, we have a kind of another cycle with generation and absorption with the pump, eliminating the gas compression. And there is another type, which is a heat sink and source called thermal compression. There is a refrigerant like helium or other kind of similar property of refrigerant. So there is another technology, thermodynamic cycle, same here, absorption, and here as in engine-driven, which is normal vapor compression cycle. So basically what it does, it absorbs energy from different sources, can be air, can be water, can be ground, and then include with just energy input to this equipment and provide heat and cool. So the metric for measuring the efficiency for these equipments is COP, per coefficient of performance. Basically, it is the ratio of energy consumed versus the energy delivered to the system in heating and cooling mode. So in gas heat pump, normally the efficiency or COP in heating is between 1.2 to 1.6, and in cooling is 0.8 to 1.8. As you see in absorption, the cooling COP or efficiency is so low. So with that, normally we use absorption for the heating only purpose, efficiency beyond 100%. So that basically the unit get most of the energy, so energy from the gas that is provided heat to the cycle, and also from the environment, and it can produce, for example, 140% of energy delivered to the space or the sink. So this is not a new technology, as I mentioned. So it has been around for a while. So in Ontario, starting in 1970s, in 80s, we had several installation just for the chilling and cooling purpose. And then from 90s and all the way now, we have been working with heat pumps and also in chilling and refrigeration with different kind of technology, as I mentioned. But why now? What is the driver right now? So why? There are three different aspects that I can talk about why we are focusing on gas heat pump right now. One is the governmental federal long-term aspirational goal, which is asking to use appliances about above 100% efficiency by 2035. Which almost eliminates any natural gas burning appliances except the heat pump that can provide above 100% efficiency. And also we have a push on the electrification that basically they want to use, government want to use or promote. I think that the key solution for reducing the GHG emission is using electrical appliance, which is a threat for natural gas appliance. And also this technology also can promote our load. So not only natural gas can be used for heating, it can be used for cooling and refrigeration as well. So the business driver for us, for Enbridge, so this is this gas heat pump offer for the reduction of GHG emission very fast. 20 to 40% natural gas can be reduced, and 3.3 to 6 megaton per year in Ontario only. And by addition of renewable natural gas and hydrogen to the mix, and natural gas with these equipment, that can be increased drastically. And also we have energy efficiency program, DSM, as Joe also mentioned, that is kind of a solution for transform market to exceed the 100% efficiency appliances. So there are several barriers for the adoption of the gas heat pump in Ontario. There are very less manufacturers that now are available or having commercialized items in Ontario, basically here. So we have only 2 commercially available kind of heat pump for the commercial sector, nothing for residential. So that's one economy barrier. So the cost of this equipment is relatively high, and some policy issues and regulatory barriers like standards, existing standards. For example, we are now promoting or working with CSA to develop the gas heat pump standards for the local market. And the main one is awareness. So the consumer supply chain is not fully aware of this technology. We have training for installation and contractor, engineer, and architects barriers, and some decision makers that's not fully aware that this technology are available. So we have done lots of activities around this gas heat pump technology. We are now working on developing a DSM program to pay incentive for the user to adopt this technology. And based on that, we are for getting to there, we are working on a lot of demonstration projects, which we have done 5 completed projects with different manufacturers. In the commercial side, with different technologies, and in the residential side as well. So residential is a bit behind. There are not any available commercialized technology, and we are expecting to get some few in that by 2022. And we have some demonstration by 2021 for the domestic hot water heating, for the space and space and domestic hot water heating as well. And also, we are very active in the other institution in U.S. like GTI and the Natural Gas Technology Institute for supporting this project, this technology. So getting to this examples and the pilots that we have done. So this is a pilot. This is a site with the 374 apartment unit. So we use 2 gas heat pump robot absorption type for domestic hot water only. So that was very successful project. We got the efficiency around 1.14 COP, 114% above. And we tested some years ago in 2005 a geothermal kind of gas heat pump. So it was another success on that. We have also tested and monitored using 3 absorption gas heat pump for Tweed Library. So it's a library site for heating and cooling, space heating and cooling. Very successful project as well. And also another kind of using gas heat pump absorption robot 5-ton unit for commercial roadhouse facility. Also for process cooling, 40-ton with the 8 units for the Golden Town Apple products. Another one we use for 2 semi-detached houses in Courtright centers for space and domestic hot water heating. Very successful projects. As I mentioned, these units in cooling, they have really low efficiency, but we are focusing for this specific type of technology absorption. We are focusing on heating part of it. So this is an engine-driven heat pump. So it is basically a vapor compression VRF system. But engine-driven. So Yanmar is having a very good products, 2-pipe system. We test one in one office building, 16-ton unit that refrigerant goes all around the building with different different indoor units, cassette type, wall mount type, and the unit outdoor provide the main, the outdoor unit provide the refrigerant compression and decompression or vibration side. So then next one is, okay, so another one is a project we have in a farmer market. So it's a bakery and a supermarket type of ish. This is a 3-pipe Yanmar VRF system, so refrigerants type that is 14 ton. So it provides simultaneous, it can provide simultaneous heat and cooling. So in 2 different zones. For example, here we have a cassette type for the retail area, and we have wall mount for the bakery area. So at some point when the bakery area needs for cooling, here needs for heating, so the heat can be moved around with this equipment, and it is make it this unit very, very efficient. So it has been commissioned since February this year, and partly in a cooling, heating mode and cooling mode. Both are very, very efficient. So the cooling now efficiency is above 1.5 right now. And these units are very good in part loading. And for example, for the February month, that vapor compression VRF system was working only on 30% of its capacity. So they're mostly running at low capacity because of the outdoor temperature that require less heat indoor. That is a gas consumption, and the outdoor temperature. Average temperature was on that month around 2 degrees C, set point inside 21, and the natural gas consumption 971, and mostly in a part load. So in residential side, we have 1 testing unit in 1 residential. So this is a SMTI unit, another absorption for domestic hot water and space heating through the hydronic going to the indirect tank, and also the air handler. So this is the unit that we installed in early January here in Richmond Hill. So just replacing the furnace with and also wall mount water heater with this unit itself. So it's working and is showing a lot of good performance. There is another technology that we are working on, is a gas heat pump water heater. So it's beyond the existing gas heat pumps, which are different type, electric type is the nearest one. So this is a new one, which is we are getting 5 to 10 pilots coming from Renai, and we are going to test it for a year in different places, and it is going to be commercialized by sometimes in 2022. So there are another kind of more expensive and a little bit lesser near to the commercialized stage. So it is early stage, thermolift and boosted from France and thermolift from US. These kind of gas heat pumps, they have, comparing to the other absorption and engine driven, they have a very high COP in cooling as well, even 1.6. And these units we are bringing in to test and see that how it can be performed, and then getting to the commercialized and supporting to the commercialized path. Other than these pilots that I discussed, we are supporting and leading different organizations. One is a North America Gas Heat Pump Collaborative. 17 gas utility is there with 20 million customers. And also in Energy Solutions Center in Washington, D.C., 50 gas utilities, which presenting 45 million gas customers. So we are also presenting and promoting this technology through these channels. So the closing remark, so we have 2 commercialized units right now. So they are very successful and good performing equipment. So we are now toward how we can provide incentive for the customer to use it. And we have a couple of new technology that we are testing right now in the commercial as well. As I mentioned, no residential is commercialized right now, so we are working on a few of them, which we are expecting by 2022, there would be 2 or 3 commercialized units from different good and high-end manufacturer as well. So we are doing a lot of effort for supporting North American natural gas industry to accelerate the market adoption and commercialization and reducing of the GHG. So these are the resources that you can, I can leave it with you. The organizations and the manufacturer, they are active in this space, and you can contact me with this information. If you need any technical information, any supplier contact or case study results, and if we're talking about Enbridge incentives. So that's conclude my presentation, and if there's any question, I'm here. Thank you.
Well, I'd like to thank Joe and Farzan for your presentations. I'm sure both are very well received by our attendees. If anyone has any questions at this point, please enter them into the Q&A box on your screen or raise your hand so that we can unmute you and you can ask the question verbally. I'll give you a few seconds to do that.
So it looks like we have one person raising their hand, Gortega. If you would like to speak, I'll unmute you now.
Go ahead, Gord.
Okay, they accidentally clicked the button. So if anyone has any questions, raise your hand or just type it in the question and answer box. I have a question in the chat. Why should they call you instead of the manufacturer?
I can answer to that. So we are working with different manufacturers, and we have done a lots of pilots. So yeah, you can contact to any manufacturer or any distributor, that's fine. But you can consider us as another source for providing information, that's all.
Perfect. There's another question. What happened to Cool Fire? I used to work on those heat pumps back in the 1990s. I think they were made somewhere in the St. Catharines area.
So there were few manufacturers, as I mentioned, since 70s, but some of them are not in the market anymore because of that not acceptance of that years of because of the natural gas price versus the electricity price. But now we have different situation and technology has been changed, and there are few manufacturers right now which are very active and they are promoting. One of them is Robor, which is now kind of selling a lot here, as well as Yanmar. I'm not aware of that manufacturer anymore. Probably they've been merged soon to somebody else. So.
Okay, that looks like all the questions that we have for now. So we'll just move on to the next slide.
Okay, as some of you may already know, Enbridge has sponsored an awesome giveaway for this episode. We will be raffling off a $100 Mark's Work Wearhouse gift card and a runner-up prize of a $25 Amazon gift card. The winner of the contest will be announced on social media, so make sure you follow us at ORAC Association on Instagram, Facebook, Twitter, or LinkedIn to stay in the loop. Thank you again for attending episode 7 of ORAC 2.0. Thank you again to our presenters. We hope that you gained some valuable information during the presentations.